Hello everybody! I hope everyone's having a wonderful day. So today we're going to be proving that n is big O of 2 to the power of n. Now, in previous videos I've talked a little bit about logarithms and properties they've had. In my last lesson I talked about how n is in fact a dominant term over logarithmic terms. So in particular that log base 2 of n is big O of n. Now, believe it or not, this statement is actually very closely related to that. So I'm going to show you a basic application of proving that result over here. So what I'm going to do is I'm going to prove n is big O of 2 to the power of n. What do I usually do? I lay out the game plan, what I'm going to do. So we find constants, c, which is a positive real number, and n0, which is a positive, what? It's a positive integer, right? It's a positive integer. Such that for all n greater or equal to n0, we know that we want to find it such that n is less than or equal to c times 2 to the power of n. So I'm going to pick c is equal to 1, and you'll see why. I'm going to apply logarithms to both sides of the inequality then we need to find n0 so that log base 2 of n is less than or equal to log base 2 of 2 to the power of n for all n greater or equal to n0. Now, what strategy did we use before that was really handy? We used the power rule, right? So notice that I can pull this down and then I have log base 2 of 2. But what do you yield from this once I simplify like that? It looks just like what we did last time. So, by the power rule, of logarithms, log base 2 of 2 to the power of n is equal to n times log base 2 of 2, which is equal to n. Why? Because this is equal to 1. Remember, 2 to the what is equal to 2. 2 to the 1, to the power 1. Hence, we need n0 so that for all n greater or equal to n0, log base 2 of n is less than or equal to n. By the previous theorem, so this was the theorem that I had proved in the previous video I did, log base 2 of n is less than or equal to n for all n greater or equal to 1. So choose n0 is equal to 1. Are we all done? Yeah, we're all done. Therefore, by the definition of big O, n is big O of 2 to the power of n. And we're done. So one other remark I do want to make is that it is in fact true that for any constant k, that n to the power of k is big O of 2 to the power of n. I'm not going to prove that here in this video, but the easiest way I can think of to prove this claim is using calculus. So maybe in the future I'll consider proving this one for you. So that being said, that concludes talking really about how big O terms relate directly with log versus just n, and a linear term like this with an exponential. The next example I'm going to do is involving exponentials. So what we can do by taking logarithms to both sides of inequalities, what can we say about those? So that's what I'm going to do next.